Welcome everyone to another video episode for General Chemistry 1, Chemical Reactions and Balancing Equations. So, we have chemical equation. The substances on the left side of the arrow are called reactants, while the substances on the right side of the arrow are called products. Types of chemical reactions. Most chemical reactions can be classified into 5 types. First, decomposition reaction. A reactant breaks down into 2 or more products. Example here, lithium carbonate produces lithium oxide plus carbon dioxide. So here we have a single reactant, and then it decomposes into lithium oxide plus carbon dioxide, 2 different substances. So it is called decomposition, the breaking down of single reactant into 2 or more products. Second, synthesis reaction or combination reaction. 2 or more reactants form a single product. This is nitrogen oxide plus oxygen gas will form 2 nitrogen dioxide. So this is the reverse of decomposition. Look, there are 2 or more reactants forming a single product. Third, single displacement reaction. It can also be called single replacement reaction or just simply displacement reaction. 1 or more active element replaces another in a compound. So here we have copper plus silver nitrate. In a displacement reaction, there is one element, uncombined element. It will displace a less active metal in a compound. In this example, we have silver nitrate, or silver will be replaced by copper to form copper nitrate plus silver, the displaced element. Double displacement reaction. 2 ionic compounds exchange ions. So we have potassium ion and iodide ion, and then we have lead ion and nitrate ion. So this will be exchanging partners or ions. So potassium will pair with nitrate ions, while iodide ion will pair with lead ion. So the resulting product is potassium nitrate plus lead iodide. The difference between single displacement from double displacement reaction is that it has a single element and combined element. In double displacement, there is none. There are pairs or compounds already. So these compounds will what? Will exchange ions. That is a double displacement reaction. The fifth, combustion reaction. A hydrocarbon or a compound containing hydrogen and carbon reacts with oxygen to form carbon dioxide and water. So this is ethane, C2H6, plus oxygen gas burns to form carbon dioxide plus water plus heat. That means this reaction is an exothermic reaction. Next, the law of conservation of mass. The law of conservation of mass states that the total mass of a reaction cannot change because matter cannot be destroyed nor created. In other words, the total mass of the reactants is equal to the total mass of the products. Balancing chemical reaction. Chemical reaction is not complete if it is not balanced. A balanced chemical reaction means that the number of each element present in the reactant side and the product side are the same. This means that both the total mass of the reactants and the products are equal, the same as stated by the law of conservation of mass. In balancing, there are rules to follow. Number one, only add coefficients when balancing chemical reactions. Remember, coefficients are the numbers that are placed in front of a molecule. Example, in 2H2O, 2 is the coefficient. This is equal to 2 moles of water, or if we multiply 2 here to 2 of hydrogen, that means there are 4 hydrogen atoms and 2 oxygen atoms. This 2 is multiplied to the elements of the molecules. Number 2, coefficients do not go in the middle of a molecule. They always must go in front of the entire molecule. It's 2HCl, not H2Cl. Number 3, don't add subscripts or parentheses or anything other than a coefficient to a chemical equation to balance it. So it's 2H2O, not 2 parentheses H2O, not H2S, not H2O2. H2O is water while H2O2 is hydrogen peroxide, or we call it agua oxigenada. The two substances are different. Number 4, don't change numbers that are already part of a chemical formula. For example, MgOH2. This is the correct formula. Do not change it into MgO2H2. Okay, let's go now to balancing of chemical reactions. Step 1. Identify the elements present in the reactants and products. Then count the number of atoms of each element on both sides. Then check if both sides are the same. If they are not, use coefficients, which are numbers in front of the formulas, to balance them. Example 1. So we have the reactants and the products, or the product. Now, we have hydrogen gas H2 plus O2, oxygen gas, will form water. So what are the elements present? So we have H and O. We write it here in the middle. H and O on the product side. And then count the number of atoms. So there are 2 H and there are 2 O on the reactant side. And H on the product side is 2, while oxygen is equal to 1. Notice that the number of oxygen are not the same on the reactant and the product side. Okay? They are not equal. So, step 2. Add coefficients. A coefficient is a whole number multiplier. To balance a chemical equation, you add coefficient to make sure that there are the same number of atoms on each side of the equation. So here, look, O is lacking on the product side, but we cannot do otherwise but write the coefficient here in is to O because there is only one product. In writing a coefficient, start with number 2 as coefficient. when balancing equations, since number 1 will not affect the number of atoms. Because look, this is H2O. It is already understood that there is one coefficient. Okay? So it doesn't change the number of atoms. So we cannot use 1. We start the lowest number to use as 2. So we will multiply 2 to H and O. So H will become 4. 2 times 2, 4. Oxygen is 1 here. So 1 times 2, that is 2. If there is no number, a subscript on the symbol, that means it is 1. Okay? Subscript, no subscript means 1. Now, let's go to the other side. So hydrogen now is lacking in the reaction on the reaction side, but O is balanced. So there's no need to add coefficient in O because it's already balanced. So we go to H. Remember, 2 is the uh, lowest coefficient that we can write. So now 2 times 2, that means hydrogen now is equal to 4. So look at the equation. So, and the number of atoms. So 2H2O, and we have now hydrogen here is 4, 2 on the product side, and on the reactant side it is 4, 2. So the reaction is balanced. Okay, 4, 2, 4, 2. So this is the balanced equation, the final balanced equation. 2H2O plus O2 will form 2H2O. And the type of reaction is synthesis reaction or combination reaction. 2 or more reactants will form a single product. Okay, let's do number 2. Sodium hydroxide plus sulfuric acid will form sodium sulfate plus H2O or water. H2O can be written as HOH. It's the same. Okay, so again, first step is to identify the elements present. So we have sodium, oxygen, hydrogen. Next, hydrogen, there's no need to write it again because you already have hydrogen here. And then we have S, oxygen, no need again to write because we already have S. So Na, S, O, and H. Okay, so these are the elements present on both sides of the equations. Then here, sodium is 1, oxygen is 5. How come oxygen is 5? Because this is oxygen is 1 plus 4 here is equal to 5. And then hydrogen, 1 here plus 2 is 3. And sulfur, there is only 1 sulfur. On the other side, we have sodium 2, sulfur 1. Oxygen is 4 plus 1, 5. Hydrogen 2 and sulfur 1. Okay? So look, of course, they are not the same. They are not balanced. So we need to balance the equation. So where we put the coefficient? Now, we have 2 sodium. We only have 1 here. So we have to add 2 to balance it. So 2 Na. So this will become what? 2 sodium. How about the oxygen? We have 2 times 1 is 2 plus 4 is 6. the hydrogen. 2 times 1 plus 2. This will become 4. Sulfur will remain 1. Now, so this is 2, 6, 4, 2, 5, 2. So, look, this O and H are not balanced with the reactant. Okay? So, we need to add some more here. So, we do not need to put a subscript or an coefficient in the first molecule, sodium sulfate, because it's only hydrogen and oxygen that is missing in numbers here. So, we will use or add coefficient before water or H2O. So we will add 2. You can add 3, you can add 4, you can add 5, but we start with 2 to see how it goes, okay? 2 times 2, hydrogen, it will become 4. And then how about the oxygen? 2 times 1, oxygen, equals to 2, plus 4, oxygen is 2 plus 4 is 6. 2, 6, 4, 1, 2, 6, 4, 1. So the equation is balanced. So we only need to write coefficient before sodium hydroxide and water. The others here, there's no need to write coefficient because it's already balanced. So the type of reaction is double displacement reaction because sodium ion, hydroxide ion, hydrogen ion, and sulfate ion. So they exchange partner, sodium and sulfate. That is why we have here sodium sulfate. And then this H plus this OH, HOH, which is equal to H2O. Sodium hydroxide is a base and sulfuric acid, H2SO4, is an acid. And the reaction between them is called neutralization reaction. Let's go to example number 3. Lead nitrate plus potassium bromide will form lead bromide plus potassium nitrate. Okay, next. So we have to identify the elements present. We have lead, nitrogen, oxygen, potassium, and bromine. Lead, bromine, potassium, nitrogen, and oxygen, the same elements. So, how many lead? 1. How many nitrogen? We have the subscript and we have the parentheses. You need to multiply the subscript to the elements inside. So, nitrogen now, 2 times 1 here. It's nitrogen is 2, oxygen is 2, times 3 is equal to 6. And then 1 potassium, 1 bromine or bromide. Next, we have lead 1, bromine 2, nitrogen 3, and potassium 1. Okay, so where is the lacking atoms? Here, we have it here. Okay, so we will try, because it is nitrogen is here. Okay, and oxygen. So we will try the lowest number, 2. Potassium will become 2. Okay. And then nitrogen will become 2. And oxygen will become 6. Okay. So, look. These two are lacking on the reactant side, KBr. So, we only need to change or add in KBr. So, potassium bromide. So, we will put the coefficient here, 2. So, potassium now will become what? 2. And bromine will also become 2. Look, 1, 2, 6, 2, 2. 1, 2, 6, 2, 2. Okay, balanced equation. That's good. And what kind of or what type of chemical reaction? Again, double displacement reaction. Lead ion, nitrate ion, potassium ion, bromide ion. They exchange partner, forming the product. Okay, then you have 10 equations to balance. Good luck. I hope that you understand and can balance this 10 equation easy. Okay. Hope to see you once again the next time we have the video. Please like and subscribe. Thank you so much.